Hello YouTube, Matt here with some cheesy Philips Hue lighting going on. Video upside down. Yo, Ben here. Actually, my name's not Ben, my name's Matt. That was a little YouTube jingle in homage to the excellent Ben from Bruh Automation. Obviously I sound very sarcastic, that's just my dry British sense of humour. No, genuinely, thumbs up to Ben. He's made some brilliant videos on Home Assistant and highly recommend his channel, BRUH Automation, I think it is. I'll put the link down below. Today I will be talking to you about hacking a thermostatic radiator valve, a TRV. Why do I want to do this? The reason is because you can get TRVs that work with something like Hive or Nest, and they cost like 40, 50, 60, even up to 80 quid per TRV. Imagine having a house full of those things. You'd be spending $1,000 on TRVs before you knew it. And also they work with a proprietary system. I don't have Hive, I don't really want Hive. I use Node-RED and Home Assistant for all of my home automation, and I very much like it. And yeah, you can't really get TRVs that you can work with your own homebrew DIY home automation system. So my plan is to hack it to make it work with MQTT and maybe using an Arduino Nano or an ESP8266. So this video is about my investigations in getting started with it. Just to warn you, the video is pretty long, dull and boring, and it's me being very waffly. So you have been warned. Feel free to not watch it or to put it on fast forward or fall asleep whilst you're watching it. I don't quite have Big Clive's dulcet tones, but you can still fall asleep while watching it if you like. It doesn't really say very much, but it does show what it looks like and how cool this thing is. So this cost me £4 on eBay. This is the Model N, which focus. Well, that's not a focus. Anyway, this is the Model N, which is there's no Bluetooth, there's no Wi-Fi, there's nothing built into this thing. It's just a 7-day timer situation, but it's highly hackable, and I'm going to show you how. So one of the things that I've been wanting to do recently is to find a thermostat which I can automate and to work with Node-RED, which is my latest home automation hub of choice. So these Drayton TRV4s, we can get TRV3s as well, I think. These are basic devices. I'm not entirely sure how they work, because I think that they actually sense the temperature in the room, and if you set it to say 3, that will essentially, it's a thermostatic radiator valve, so it will essentially, I don't know what this number refers to, whether it's a kind of a temperature calibration or something like that. But we certainly know that if you set it to max, the rads will be on full. If you set it to min, they'll be not on full. They'll be completely off. And if you set it halfway between, I think what it does is it will essentially measure the temperature in the room, and something inside here will expand or contract because of the temperature. And it will set this pin. We'll set the pins on the end of the radiator, which control how much water goes in by bringing this actuator up and down. So I think what we're seeing now with me turning it is going up and down. I think maybe if you set it to that, if it expands when it gets hotter, perhaps the pin will push in a bit, which will stop the water flowing in, and therefore the radiator will not get as hot as a result. Perhaps that's how it works. I don't really know, but I just know I want to automate this thing. So I found these excellent little things, and this is called the Equiver. Let me pull up the model number. And I found these on eBay actually, a couple of these for £4 each, but I think they were being sold second hand, but they were brand new in box, so I was quite happy with that. And so this is the Model N, the Equiver Radiator Thermostat Model N. Now I believe that the Model N actually is not Bluetooth, and it is not Wi-Fi, and it's not anything special at all. All it is you can set the time, there's a kind of like a timer function on here with a 7-day timer. You can set it, and it's all really difficult to do from this little screen. But I have to say, given that it is from this little screen, they've done a beautiful job of designing the interface. So I'm going to show you, and we're going to start hacking this thing, because it turns out, I've taken it apart, it's really, really hackable. So first of all, let's go through what the instructions say, put the batteries in, and see how the thing works. So we pop that in there, and pop that in there, and you're going to see it booting up, and then ints. Now when that little thing is turning around, what it means is that it is, there's a little motor in here which turns the pin, and it's geared down, and I'm going to show you that in a minute. First of all, it lets you try to set the date, which is 2018. Let's set it, well, I'm not going to bother really setting this. I think it's the 11th or the 10th or something today. I'm still in post-Christmas mode where I have no idea what the date is. Now, when it says ints without the little counter, it means it's ready to install, which means that this pin is fully retracted. Now, if I press this, it says ADA, and that means the pin is pushing in now. And I'm going to show you it going around. If we can focus on here, you can see that little thing is going around very, very slowly. And it takes quite a while. It still says ADA, and then when it's finished, it stops saying ADA. So this is assuming that you've put it on the radiator now, and it's pushing that pin down. And what it's actually doing is it's calibrating to see how far it can push the pin down. And then there's a little mechanism in here that works out when that motor can go no longer, and then it calibrates that. I'm going to take it apart now to show you exactly how it works. But first of all, let's go ints again, so to fully retract the pin. If we can see this on here, put some light in there. There we go. It's now retracting the pin very, very, very slowly. What's actually happening is there's a weak but fast motor inside, and a whole load of gears, which mean that it is able to exert quite a high force, but not very, but the throw of this pin is not very far. So now it's finished. So let's take this thing apart, and let's see how good it is for hacking, which is what we want to do. So first of all, you're going to need one of these little, let's see if you can focus on here, one of these little these little Torx drivers. This is a mini Torx driver to get these little Torx screws out. And now I know, because I've done this before, the wonderful thing about this device is it is really hackable, by which I mean you can take the whole lot apart, you can even expose the gears and put the whole lot back together again and have it working exactly as it was before if you wanted to. I'm not going to, because I'm going to hack it. And my idea is to use an ESP826601, which only has one output. But I'm going to see if we can get this little thing into here. And I'm pretty confident that we can. But we've got a couple of hurdles to get through. And I'm going to show you what they are. I haven't really designed this yet, or fully thought it through, but I thought I'd do a little video just showing you the system. So now I've taken those pins out. So first of all, this is the battery cover, and it just kind of clips off. And then you need the little Torx screwdriver to get the 4 screws out. And then you just gently pull, and you're going to see in here the rotary controller spindle, which is this thing here. And it's actually a pushy button as well. So it's a, I'll just show you where that pushes onto here. So that pushes onto this little SMD switch. And then we've got 2 other buttons. Now, I'm not really interested in what these buttons do or how to set the 7-day programmer, because I'm old and my brain hurts when it comes to 7-day programmers with little fiddly things like this. So what I really want to do is get it working in Node-RED so I can kind of do it programmatically myself through my server, because that sounds like much better. The nice thing is this little display pops out, and you can put it back in again. Now when the case is off, in order to see this display, you have to kind of put your finger gently on there, because the case actually applies a pressure, which we can simulate by pressing that in. Anyway, we don't really need to take that out, because the beauty of this is that this now slides out to reveal a mechanism which is a completely standalone, and this is why it's so good for hacking, a completely standalone mechanism which you could put on. This is an M30 thread and will be compatible with our Drayton. I think most UK radiators have this M30 1.5mm thread. This one's a plastic one versus the metal one, but it goes on perfectly well. But yeah, this is a completely standalone kind of device now that we can apply a voltage over these lines here and have it go on and off. But there's something that we're going to have to do first. First of all, let's just quickly check the voltage. So I don't know if you can see this, but set up to voltage DC. Pop those batteries back in. Oopsie daisy. And something right around. Right. Now, this is already doing its weird kind of manual calibration thing. It's now calibrated. Because I've taken the display off, you can't see, but I happen to know now that this middle button, which is the rotary controller button, essentially does the pushing of the pin and the retracting of the pin. So if I press it once, well, that was clearly, oh yeah, there we go. Let's try that again. There you see, you can see it going around there. And I press it again, and it reverses, going back to INTS mode. And INTS mode is where the pin is fully retracted, because of course the little pin on the radiator sticks up, and then you screw this on, and then to actually close the valve you then have to apply the pressure downwards on most standard radiators in the UK. So let's see. Oh, look at this. We've got these two little pads here. We can just pop the voltmeter onto. So let's just do that now. Can I hold it and press the button at the same time? That's the question. Right, oops. Well, it's a little bit difficult holding all this stuff at the same time. I don't have a special rig to, oopsie daisy, hold this on. Let's pop that there. I need to do that, and I need to pop this one here, and then press the, right, we've got 0 volts, and then if I press the thing which pushes the pin down, well, I've obviously not got enough contact on these things here. There we go, 2.69, 2.66, 2.66 volts, is that? Back on. Yeah, and now the pin is pushing down. So if I press this button again, you won't see me pressing it because I'm just going to rock this finger here. Bop, oops, and you can see it's now minus 2. Very difficult to hold these on the pads. Minus 2.6 volts. Sorry, it's failing. There you go, minus 2.6. So that's with the pin coming up. So essentially we know that this thing works on 5 volts and it's a voltage divider, and it applies negative 2.5 volts or 2.6 volts to push the pin down, and 2.6 volts to bring it back up again, so to retract it. So just to cut in, the main thing that we want to know from this exercise is how the microprocessor in the device knows when to stop applying voltage in either direction. because obviously when that pin is fully retracted or fully thrown, the motor's no longer going to be able to turn. And I'll talk about that after taking it apart. But one of the reasons that I really like this device is that the way it's designed is that the motor is so weak that it won't force the gear cogs, which you'll see shortly. In fact, I reckon even if the motor wasn't that weak, those cogs are super robust for such tiny pieces of plastic that they are. Anyway, more on that to follow. So let's have a quick look inside here, because I think this is where it gets kind of fun. Now, when I first took this apart, it somewhat concerned me. Now, we need to use a slightly bigger one for these screws. It somewhat concerned me because a whole load of a whole load of cogs popped out. And I thought, I'm never going to get this back together again. But because this is such a wonderful hackable design, the mechanism of this is beautifully designed. And I'll show you why. Let's just undo this here. Screw number 1. Let's get that out. And screw number 2. And what I'm going to do is I'm going to hold this upright like that. As you will see, there we go. There's a little pin in there as well, which screws falling out everywhere. There's a little pin in here which we can just pull out, and there it is. So this is the mechanism. Oh, first of all, here's the motor. It's a very stubby little motor with a cog on it with nice metal screws that go into the metal casing of the motor, so it holds it very nice and tight. And then this is the gearing system, and what I wanted to do was to see if this gearing system would, withstand, accidentally putting 2.5 volts onto this motor, and I wanted to see if it would withstand being kind of overdriven, see if the cogs would kind of stop working, in case I get my calibration wrong. And I think it will pretty much withstand it, but I'll take these out, and then I'll take this cog out here, and then this just lifts off. You see that? And then there's 2 more cogs. So this cog comes out as well. And I'm not really caring about where I put them because I know how easy it is to put back together again. And then this is not going to come out, and the reason for that is because this is the thing that goes in there. But in order to get it out, I'm going to unscrew it, and there it is. You can see there's a little thread in there, and then there's a thread on here, and this is a big cog. So that's how it works. So pop this back in. And of course I'm doing this extremely fast, but the motor, it will be stepped down and much slower. But of course I wouldn't be able to turn this with my finger once it's attached to the radiator, because I wouldn't have nearly enough torque. Is torque the right word? Well, I don't know. Anyway, so you can see this is what it looks like when it's fully out, and then when it's retracted it looks more like that. Now there is a limit to how far this can come out without the cogs popping out, but this has been so well designed. Let's just put this back in here, and you'll see this steps down the speed of it once. But if you see, I'm going to try and catch the light for this video. If you can see, if I bring this all the way out, I'm trying to show you, that's all the way in now. So if I bring it all the way out, what actually happens is this, the bottom one comes up and up and up and up and up, and then it pushes that cog out, see? But the good news is they thought of that, because that's where this thing comes in. Pop that on there, bring it almost all the way out, and when I'm undoing it, the top cog is going the other way. So that's almost all the way out, I don't know if you can see. But if I pop this on now, and then I continue going this way, you're going to see that, I don't know if the light is good enough, there we go. It just stops, and I with my finger, I cannot make it go anymore. So it's basically butting up against the plastic in here, and it's just stopping. So that is really good. That just shows that it's very solid. It's not making those cogs nice. Superb. We like that. And then these two little spindles. So first of all, the nice thing about it is that this cog here has got a teeny tiny spindle there and a teeny tiny one there, and they are held in the bottom and the top little hole there. So that's nice because it just means that it's held in firmly. And then we've got these two little spindles here which just come out. They've been a bit pre-greased, which is good. Put that one in there. They're exactly the same size, so you can't get them the wrong way around. And that one there. And then we've got to take this one, which has got its own axle on there. Let's focus on that. And that one goes, obviously. So the thing about this that I like is it's very obvious which way it goes back. That obviously goes in that hole there, doesn't it? So let's pop that in there, and sure enough, that's going in. Let's do it that way. And that's what I was talking about. It's fully retracted, and it just stops. It just doesn't go. It doesn't. The cogs don't. I mean, they don't grind. They don't miss a cog. It's really good. And of course, this one is retained as well when we put the top casing back on. So I've got these two little spindles in here. And now, which way round do they go? Well, these are ever so slightly different, so it will matter which way round they go, but I'm sure it's easy to work out. Put this one on here. That does seem to go on that one. Let's try to see if the other one does go on that one as well, just to make sure. Let's pop this back on. This is the other one. And now that does also go on there, but I think if I pop that on there, yeah, that's definitely the wrong way around because it feels very loose and you can hear it. So let's pop this one on here and then pop this one on here. As I say, it's not like a watch mechanism that, you know, a spring pops out and then you think you're never going to get it back together again, because it just goes back really easily. And that's it. It's all back together again. And then when I turn this one, it essentially, it does turn in here, but just extremely slowly. You can barely see it. Like you cannot see it. And that's because this motor runs really fast. So let's pop him back. I'll have to take the whole lot out again. Pop this one in here. That one back there. And then, yeah, as I say, these little spindles are actually braced on the top as well, which is really good. There's two little holes, one there and one there. Or perhaps they're these two holes, aren't they? Anyway, I took the motor out as well, but I realised there's no real reason to take the motor out. Tell you what, let's just take it out anyway for this video. This is a normal Phillips head, 0 I expect, very small. One's out. Two's out and three's out. And that's the little motor. So what we really need to do is to work out how this system knows when to stop turning the motor. And the instructions here say, after the batteries have been inserted, the motor reserves. I think it means reverses. I'm not sure what it means. Meanwhile, the date, ints, and the activity symbol, that kind of scrolling thing, are displayed. As soon as ints is displayed without the activity symbol, the radiator thermostat can be mounted. So that's when the pin is fully retracted. This is followed by an adapting run, ADA, to adapt the thermostat to the valve. So it will know at some point when to... so there's some kind of feedback system, and given there's only 2 wires going into this motor, there will have to be a current sensor. So let's just pop these batteries, which I've misplaced on this desk. Probably right in front of me, but I can't see the things. Well, I'll tell you what, let's leave that aside. Over here. Batteries are in the thing, obviously. Right, and then, oh dear, my LCD strip has come out. That's probably never going to work again. I think it went this way around. And I think that went there. What happens if I gently press? Oh, look, it works. Gently press on there. So INS means it's fully retracted and ready to install. See if I can keep that on there. And I'll see if I can show you what's going on with this motor. If I pop that in there, perhaps you can see the whole lot. There we go. And then I'll keep my thumb on this middle button, which is the thing that kind of starts it going. So if I press the button, you can see it's in the ADA, and it's just freely spinning. Now what happens if I pinch it? It does a quick kind of change direction 3 times and then says F3, which in this manual means adjustment range too small, check the heating valve. So I think it probably thinks that it wasn't able to adjust the heating valve belly at all because it was only running for about 1 second. I think it probably might even run for about a minute to push that thing down. Anyway, now we're in F3 error. We're going to have to take the battery out and pop it back in again. So the way that we can test whether this is going to work or not is, oh dear, this has popped off, is to let the motor run freely and see what happens. So we're in set date mode, so I'll just go through this menu until it's done. Now, this thinks that it is not fully retracted and it is fully retracting it. And I cannot tell you which direction that motor is going, but it doesn't really matter. So it thinks the pin is down and it's bringing it back up. And it will continue doing that until there is resistance, a physical mechanical resistance on here, which I'm going to simulate by pinching it. And watch what happens when I do. Pinch. Now, I think that there is some current sensing going on in this board that detects... I don't really know how this works. We're going to have to look this up because I'm not knowledgeable about these things. But there is obviously some kind of voltage or current sensing going on such that when this can no longer turn, it knows that it has finished and that it should stop, and that's part of its calibration routine. So whatever we design to hack this thing, we will need to have we need to implement that sensing and that calibration routine. And I guess that will be for another video, but for now, let's just see if we can work out the calibration routine. So now the pin, well, it thinks the pin is fully retracted. So let's press the button. I should probably time this, so 25:16 is when I start on my timer. Now I wonder if it's pre-calibrated, so this is going around currently. I wonder if it's pre-calibrated to know when to stop this, i.e. when the pin is now fully extended. Let's leave it for some time. I'm not going to pause the video, I'm just going to upload it in its raw format, so do make use of the 2 times speed, or I'll just talk about, you know, daisies or rabbits. Drinking water, which on a Friday night is very non-standard. Do we have any beer? We do have a very nice one. Is it in the fridge? Yeah. Excellent. Right, we've gone for 1 minute. I think. It's still spinning and it's still doing its routine. Do you know, I think what we're going to have to do is put the thing back on. Now, what happens if I pinch this now? Let's pretend that I'm the radiator saying, yep, you can't push down anymore. Now, it's gone into kind of this error mode again, so I'm not sure. And when I pinched that, I felt it change direction very, very quickly 3 times. It went like that. Maybe that's 4, isn't it? Anyway, now let's put the whole lot back together again. Let's put this in here. Let's put this motor back in. Let's get that the right way around. So I can see the holes. I can. Up there. Put it so my viewers can see it. Oh, before we do, I should probably get the model of this motor, shouldn't I? What does this say? I don't know if you can see it, but anyway, I can. That says SHRF, or SHD at the bottom, or RF at the top, 300C, and then 08550A. And then the numbers underneath say V3.0, presumably that's 3 volts. And then 180602. Wonder what that means. Let's look that up later. Anyway, you can see what I'm getting at here, and that is that this thing is wonderfully hackable. We just need to cut these wires off, and then this entire unit here, that plus that, can basically pop onto the radiator, and we can put a ESP8266 or an Arduino Nano or something like that, connect it up, apply some voltage, and then it'll be good to go, won't it? We'll write a little sketch. Anyway, I will pause this part of the video and I'll unpause when it's put back together again. So before I put this back together again, I should show you what happens when let's get the light on there reflecting. You can see it is geared down tremendously, and this bottom one on the left, on the left now, actually, that one is geared down as well, so it'll go much slower. I can't really turn it upside down and show you the effect because the whole lot will fall out. But anyway, now I've found all my bits, might as well just put this back together on screen. Pop in there, get the big screw. These 2 big screws over here. And it's just so nicely, I mean, the mechanism's just beautifully made because everything goes back together again really nicely. Must be made by the Germans. I think it is made by the Germans. That's what they do. There you go. Just even one screw just holds the whole lot in perfectly reliably. But oh no! Look what's happened. Oh well, I'm gonna have to work it out myself then, aren't I? Oh well. Or resolder it, which is the other possibility. Let's put that back on there. Get that nice and tight. And it's in. Lovely. And just look how it works. Look how this goes in. It just no screws. It just scoops back in. Is that the right way around? Probably not. No idea really. I've totally screwed these. It scoops back into this little. There you go. See that? And on that side, and it just pushes in. He says, getting it the wrong way around. Try this way. Yeah, that's that. Just pushes back in, and it's a nice design. Anyway, what I'm going to do is I am not going to take this all out. I'm not going to just use that on its own because that looks fugly and I'd have to get some mounting. What I'm actually going to do is I'm going to leave the whole lot connected. I'm going to take this little board off because it's going to be surplus to my requirements. I'm going to take the battery mechanism out and I'm probably going to cut. Let's just show you what I plan to do in my head, although this may not actually work out in reality. I plan to kind of cut this here. I'll easily get an Arduino Nano in there if you cut this bit of plastic between there out. And it just means that, either that or I'll put one of these in here. take that out, whatever, there's enough space you can see for that. And then I'll put this all back together again, whichever way it goes round, and then it won't look too awful. I might even see if I can get the LCD back in, just to, I mean, it will be blank, I'm not going to use it, but just to make it look not too bad. The other thing I'm going to do is I am probably going to, because obviously the ESP8266 is not going to work for 3 years on battery like this, so I'm probably going to have to think of some power, getting power to it, and I'm thinking the best way might be to only install it on radiators where I've got a nearby mains power socket, and then use a 5-volt USB charger and cut a little 5-volt power supply into the back of it. Seems simple, straightforward, cheap and safe. And the only thing that remains is to write a little sketch for the Arduino Nano, which, or for this ESP, which will work out the calibration, and also to do a bit of research to find out, you know, how this board knows that the motor can no longer turn. This is probably blindingly obvious to more experienced electronics people than me. I suspect it's just, you know, there's some kind of current sensing circuit in here. But that's what I'm going to have to find out and try and implement that myself. Anyway, I'll update you with this project when I progress it. Thanks for watching.